All right. Hi, everybody. So we're going to start here. But before we start, a reminder that we have class tomorrow, right? I think I mentioned this. I hinted at the fact that we're going to have to make up for the missed class. So we have class on the 7th, which is tomorrow at 18 hours, same time. And then, more importantly, I almost always have to say this, but we have a test on Thursday. It's at 18 hours. The venue is going to be, well, the venues are probably going to have to find a third venue here, but tentatively it's the Michael K. Lecture Theatre and also the Mat Lab. Trying to make arrangements so that we have a third venue. I still feel like we are too cramped in that. So take note. And you probably want to show up for the test, right? I don't, I've mentioned to people that have come to me asking for makeups that makeup assessments are extremely expensive. They're only administered when there's proof, right? That you were unable to attend because of something very pressing, like a funeral, or if you are sick or something. Or in the case of, I think, is it 2 or 3 individuals who are participating in so-called Zamren week, right? So if you think that you're going to miss an assessment and then just walk into my office and or send an email and request for a makeup, you're mistaken, right? No makeup is going to be administered for you, or to you rather. So just take note. Yeah, and then I will be sending out details of the presentations. I just need to finalize the venue. The venue is going to be the seminar room. What's going to happen, that's either Thursday, you want to prepare here, Friday. I'm going to start processing you in the morning here because it takes a long time. Each one of you will have 10 minutes. There's a lot of you. 10 minutes plus feedback is probably going to be like 15 minutes for each group, at least. So you'll be taking turns, ideally because this is an assessment, you will not be allowed to attend presentations that are being done by your colleagues, which is why we're using a very small venue here. So we'll only be allowing individuals who will be presenting at that point in time. We'll send out a schedule of how exactly we're going to be processing you. So take note. And I hope you're making progress in terms of preparing the final reports also. There's supposed to be a report that you're supposed to submit, if you remember. Anyway, we're going to continue our discussion of lecture series number 5. And, you know, I've had a bit of trouble here kind of trying to structure this, right? I feel it's going to be helpful if we look at the high-level theoretical stuff associated with the modeling stage of the CRISP-TM methodology before we start looking at code, right? The other option was going to be every time we discuss a concept, you know, include kind of like code constructs or something like that. But I've decided against that, right? So we're going to look at the theory, which I anticipate we're going to finish today, and then beginning tomorrow, I'll start showcasing code examples. Okay. So a reminder that we had a discussion, right, of this. I think we parted ways when we were discussing this table here. In essence, looking at these broad features associated with supervised machine learning and unsupervised machine learning. Here's to hoping we understand the subtle differences between supervised machine learning and unsupervised machine learning. So for instance, the goal for supervised machine learning is to predict an outcome, you know, so a numeric value, a category, in essence, a class, numeric value. Whereas for unsupervised machine learning, the goal is to discover underlying patterns or groupings. So you don't know what it is you're looking for. You're just looking for any interesting patterns. And generally, this sort of technique is employed when you're trying to detect certain things, like anomaly detection, for instance, right, or fraud detection and all those things. And then with in regards to input data, we realize that for supervised machine learning, your input data, because if you remember, we mentioned that most of these things, these models that we're implementing, supervised or supervised or unsupervised machine learning, we typically they have something in common, right? You're working with some mathematical function. Y is equal to f of x, is it? Yeah, where the y is what you're interested in here. I'll call this outcome, and the x's, right, which I use as input to your function, would be the input parameters, right, or the input features, in other words, right? So what we are saying with supervised machine learning is that this outcome, the thing that you're interested in outputting from your model, well, is a category or a numeric value, right, for regression and classification. Whereas for unsupervised machine learning, this y here is a pattern, right? So it's either you're predicting some sort of class, for instance, a category, a number, or you're outputting a pattern, right? You're trying to identify a pattern that exists. Now, the inputs we see for supervised machine learning, the inputs would be your labeled data, right? So the labeled data is created in such a way that you identify the different sort of input features that are being used to learn your model, right? Or the different input features that are being used to learn your model, and corresponding non-values of the outcome, right? So it's labeled. And usually this labeling takes quite a bit of time, right? It's very tedious. In some instances, it will require money, a lot of money. And in fact, this is big business. Please tell me, some of you have heard of, I have a family friend, or she's like family anyway. She calls me, she's a student, Ridgeway campus, right? She's doing radiography or something. And she tells me, Lighton, do you know anything about Yenda or something, right? And she sends me a link, right? And apparently Yenda have taken Zambia by storm here. They're identifying people to work for them and stuff. She tells me, I was told to do something. I performed the task. I sent them the results, but they haven't yet gotten back to me. It turns out that what Yenda is doing, or what Yenda does, is in the business of creating labeled data. Because everybody is interested in this AI stuff, is it? You know, organizations are looking at implementing AI solutions, and typically for most of these AI solutions would leverage supervised machine learning. And what that means is that you need labeled data, right? Now typically you need tons and tons of labeled data. And the easiest thing for you to do is you hire people to do the labeling for you. I don't know how many of you have, maybe one if you've heard of Yenda, or if you've interacted with Yenda before, you've worked for them, and 0 if you haven't. I'm just trying to have the sense of this in the chat, please. So there's that, right? And then, you know, because machine learning, by the way, if you can manage to type something in the chat, 1 if you've heard of Yenda, or you've used Yenda, and 0 if you haven't. But what are you guys doing here? You know that they do micro jobs, so you can be busy with school, but you can still do a bit of work for you, and then they pay you money, right? Yeah, you probably want to look into Yenda. They've taken Zambia by storm here. In fact, if you go on LinkedIn, what you notice is in some instances they're looking for labelers, data labelers, for instance, to help with translation and all those things, right? And then, just to mention, just to give you an idea of just how serious this thing is, there's been an uproar, right? I think Kenya data labeling protest or something. I don't know if it's protest, but there was they've been protests in Kenya, for instance, right? On how unfair most of these Western countries are. And so what they're doing is they've realized that places like you know, the Indian subcontinent and Africa especially have a lot of people, right? A lot of people that can be paid peanuts when compared to how much money they would have to pay to data labelers in their own organizations. So what they do is they offload this task to African countries, or India, for instance, or South Asian countries. You want to look this up here. There've been a lot of protests about how people are abused, if you will. So they're given significantly less money than the money they'll be given if they were doing the same type of job in a place like the United States or something like that. So this is big business, actually. And what you begin to notice is that, not this is here, but what you begin to notice is that increasingly, as the uptake of I want to say of AI, right, increases in Zambia, it's just a matter of time before we get to a stage where this is happening in Zambia as well. Not the protest, but a lot of companies looking for data labelers. You know, it turns out that this is something that is quite evolving. So the input is labeled data, and then for unsupervised machine learning, the input is unlabeled data. Now, generally, what this means is that for supervised machine learning, all you have as input are your features, is it? You don't need a target, because the target comes about when you label your data, right? You're associating a target to the X, which is fed into f of X here, right? And then in terms of training here, we see that when you're learning the model for supervised machine learning, the model learns, or you're teaching it a pattern, yeah? A pattern between the input or between the input features and the target. Whereas for supervised machine learning, the model learns the inherent structure of the data. It's like what we are doing to you, right? Or what we would be doing to you as you are preparing for the exam. We tell you to say, here are some questions, some past exam questions, right? So you're given not just the questions, but the model answers as well. And the thinking is that when you go through those questions and corresponding answers, when you are in the exam, you are more likely to get most of the questions right, because you've been trained on that. That's, in essence, this is how supervised machine learning works, right? Of course, it's not as simple as that, you know? And then finally, we looked at, like the specific tasks, if you will. So for supervised learning, we see that the primary tasks that you'd be working with here are classification, where you are interested in predicting a category. You know, so it's like a grouping, right? A restricted set of values. Or you could be interested in predicting a numeric value. Now you soon notice when we get to look at actual supervised machine learning that in actual fact, classification is clustered into three main types, right? You can predict true values, right? It's like a yes or no, rich, not rich, or poor, not poor, something like that. Fair, right? It's a one or something like that, binary classification. Or you can have what's called multi-class classification, where you're predicting more than two classes. So it's like we want to build a model that's going to predict. It's going to predict whether someone is going to get an A plus, an A B plus, a B, a C plus, a C, or a D. These are multi-classes, right? Or alternatively, you could say we want to build something that's going to help us predict what's called multiple labels, is it? Multi-label classification. So this notion that you can have a restricted set of values that you'd be calling targets, and the output can be multiple such target values. So typically a nice example I like to use myself is especially when I'm teaching people like you, is Stack Overflow, is it? I don't know if you guys are still using Stack Overflow. If you heard of Stack Overflow. But if you go on Stack Overflow, what you notice is that the topics are with labels, is it? Labels that correspond to, or the questions, the threads are tagged with labels that correspond to different topics associated with a question or the tag itself. I'm going to pause here. Miss Mlela says my network is intermittent. Is this the case for everybody else? I want to switch if that's the case. Or could somebody maybe just confirm if they are at least able to hear me without a problem here, so that we rule out the possibility of whether I see thumbs up, I see yes.
No,
I don't know
sir,
what that yes means, right?
You keep breaking.
Okay, so it's breaking from time to time. And switch to liquid is failing me. I do apologize. Is this any better? Is this better than before?
Yeah, now we can hear you.
Okay, I've just switched to.
Yes, sir.
Yeah, thank you very much. So I'll give you an example of Stack Overflow. Right? If you look at Stack Overflow, if you have a thread like this, I don't know if you guys use Stack Overflow because the world has changed here. You know, when I was a student myself, we would use what thing was that? I've even forgotten. It used to be a popular. Popular platform where you go to find solutions, and then Stack Overflow came onto the scene and took everybody. I mean, the entire thing by storm here. But if you notice, a thread on Stack Overflow will be given these labels, is it? So in this particular case, this particular thread is tied to deep learning, intrusion detection, and IDS. Now, if you wanted to build a model, which when somebody just types a title and a description of the thread, a question or something on Stack Overflow, it automatically assigns these labels. It turns out that what we'll be building would be a multi-label classifier, right? Because the way it would work is it would attach different sort of labels to each forum question in this particular case, you know, so multi-level classification. And then there's regression, like I said, which really makes it possible for you to predict a numeric value, right? Like rainfall I gave as an example. And then there's unsupervised machine learning where you'd be interested in patterns, like I said. So it could be dealing with association, right? And then also clustering, right? Groupings. Identifying patterns in your data or something like that. And what I hinted again was at the fact that this is an equation that will probably help you understand what it is we're going to be looking at, right? When you're learning a model, what you're doing really is you're implicitly working with a function f of x, which will yield y, is it? So in essence, you're working with the equation y is equal to f of x, really. Where x, by the way, we'll talk more about this, but x ideally comprises of a range of values, right? We're simplifying this when saying this is f of x, because it turns out that your x can be equal to a set comprising x1, x2, x3, you know, all the way up to xn, where 1, 2, 3, and n are your different features. If you remember the students at risk of failing dataset, you remember that there are a lot of features, is it? There's things like gender, right? So x1 could be equal to gender. You know, your x2 could be equal to sponsor or something like that. Your x3 could be equal to accommodation status, right? You know, and so forth, so forth. But anyways, so it's not as simple as that. Yeah. And it turns out that whether you're leveraging, you know, supervised machine learning or unsupervised machine learning, a key prerequisite to solving any machine learning problem, or really any AI problem, really, is to have access to reliable data. This we understand. This is the reason why we spend a great deal of time discussing the data understanding and data preparation phases of the CRISP-DM methodology, to make sure that by the time we get to a stage where we're modeling, we're creating these models, we would have access to quality data. Usually, you know, when you fail to find quality data, you just abandon, you know, you abandon the mission to create this model, or you create synthetic data or something like that. Anyway, so what we're saying here is that transformation, again, is necessary, right? Because most of the estimators that we're going to be looking at, and it's going to be a very mild introduction to estimators because we're only remaining with very little time here. We won't really go into the gory details of how decision trees work and how, you know, k-nearest neighbors works, you know, how naive Bayes works and stuff. we want to focus our attention on how exactly we get to use those things by leveraging scikit-learn, right? In other words, anyway. And just to mention here that this representation, the y is equal to f of x, is obviously contextual, right? It depends on the problem domain and your goals. And again, this is the reason why your business understanding becomes important, because it's during business understanding that you will get to appreciate and understand the representation that is necessary for you to solve the problem, right? So you discover that, oh, the range of features that I would need are these, right? Typically, for most problems, for people like you, or even me actually, you would have to engage an expert during business understanding, and that expert will tell you, for instance, say, for you to predict the basic needs and nutrition basket for the JCTR, you would have to make sure that you incorporate important variables like the exchange rate between the Zambian kwacha and the South African rand, between the Zambian kwacha and the United States dollar, for instance. They'll tell you to say you'd have to take into account volatility, right? As it relates to the different periods of the year, because certain interesting things happen during the year and all those things, right? And using that information, you'll be able to identify the range of X's that you need to incorporate into this model that you're implementing. Now, in some instances, you'll have to strike a compromise, because it may perhaps not be easy for you to get information about certain important variables. I gave an example of political climate. If somebody, an expert, tells you to say political climate is an important predictor of the BNNB. So if you're looking at predicting the value of the BNN, the basic needs and nutrition basket for Lusaka for December 2025, what you need to do is you'd have to understand the political climate or something a couple of weeks prior to December. Well, but it's like, how easy is it for you to do that? You know, if it's difficult, then you drop that that label or something. Anyway, so this is what I was saying about supervised machine learning. It involves the use of labeled data, and the labels are the resulting output of the algorithm. So the labels are the targets, right? And we see here that learning the model involves training, is it? So you're showing the label a mapping between input features and corresponding targets that have already been identified. Yeah? When you see these features, this is a target. These features, this is a target. So that when you start predicting, right, when you run inference on observations that this model that you've learned has not seen, there's a high likelihood that it's going to show you the correct thing, or it's going to spit out a value that is closer to the truth. You know, and we see really that the accuracy, right, or the performance, the effectiveness or efficacy of such models can easily be measured, right, by looking at the accuracy. Because if you have labeled data and you use part of this, usually standard practice, part of that data is used for training. After you train the model and you're happy with how it works, you can then use the part of the data that has been reserved for testing in this particular case to see how the model is going to perform. You know, you do not test the model with the same data that has been used for training, because you know it's going to tell you that maybe the accuracy is 100% or something like that, right? It's like you, as you're preparing for the exam, right? We will show you, we'll tell you to say, these are past exam questions dating back 5 years. Here you go, right? So you have an idea of what to expect. If it come, is it, I don't know if it's October or something, and you're writing this test, we bring the same questions from last year or the year before, you're obviously going to get everything right, yeah? This is what happened with the quiz, you know, because it's like we are telling you to write an assessment based on the things that you've been trained on, right? The training in this particular case were the examples that were being worked on in class, you know? So anyway, so accuracy can easily be measured here, we see, right? And really predicting an output, like I said, again, the goal is to predict an output f of x given an input x, and f of x is equal to y in this particular case, is it? Or given input x's, right? So this x comprises of multiple different types of x's. And we see here that if f of x is categorical, right, You remember the different data types? Numeric versus categorical attributes. So if the f of x is categorical, then we're solving a classification task or problem. So in other words, what we're saying is, if you are interested in predicting something like sale, pass, this is a categorical attribute, is it? It's a category, right? If you're interested in predicting this thing that I was giving here as an example, the data type for this, if you remember, is, again, this is, if you remember, dichotomous, right? This is nominal, right? In other instances, you may find yourself predicting ordinal attributes as well, right? So in other words, the thing is, when you are working on a task that requires that you, where the f of x is, I don't know if you can, Captain Aya, I don't know if you are raising up your hand here. Yes. You can mute your microphone. Okay, yeah, thanks. You can mute your microphone, that would be nice. All right. But we see here that if your f of x, right, is numeric, or it's a continuous attribute, you remember that? If you're predicting a grade, an actual grade, you want to predict whether what exact value, what grade, what specific score each and every one of you is going to get in the exam. It'll be fun here, right? In fact, I think try and see if we can build a model like that, where we want to predict, like, what score are you going to get in the final exam? You know, are you going to get 50%, 60%, 70%, or something? So 0 through 100 is a continuous attribute, right? Because it's continuous, what we're calling this is a regression problem, right? Anyways, I hope you're taking note of this, and I have a series of examples here. Please, at your own time, I do encourage you to read these papers. If it's too much to read, at least just, go to the URL, in this particular case is DOI, and just go through the abstract, right, and see what this is about here. An interesting paper here on data-driven intervention, prediction modeling for academic performance. I like using this as an example because Mgala was a colleague of mine. In fact, we used to sit in the same cluster in our lab. He was on the other side of I guess the table where we used to sit here. So we chat a lot about his work, and I remember his supervisor being not so very happy at the very beginning of his PhD, right? Because he had gone to collect data, and what he was planning to do, believe it or not, was at the time, during inception of his work, he had identified a key variable, right, of religion. And one of the assertions I remember that he had mentioned was that this part of, I guess this part of Kenya had a lot of people that practice Islam and stuff, and there was mention of certain days students or pupils don't go to class and all those things, because of Friday prayers and stuff, and the supervisor was not too very happy here. Ethics come into play when you're doing those things. But in this particular example, really what you see here is that the intervention was the intervention here. I mean, the task itself is purely classification task. And to be specific, this was binary classification, right? So what he was interested in doing is learning a model that would be able to indicate, to say, this pupil requires high intervention, or he or she requires low intervention. And in case of the X's, the features that he was using, or he used to learn this model, is he used as input test scores, gender, age, motivation of the student, and the amount of time that the student was putting in terms of studying, I guess. Sometimes some of this data may not really be reliable, right? Because if you look at things like study time, the only way you can get this sort of information is by asking a student, right? It's like me. If I wanted to learn a model like this, and study time, the amount of time you put into CSC 4792, the only way I'll be able to get this information is I would ask each one of you to say, how much time do you spend per week, right? Reading or studying CSC 4792. Now, this is not going to be accurate, it's going to be an estimate. In fact, if I ask you per week here, it will be difficult for you to quantify that, right? Maybe you probably approximate things by referring to the previous week. It's like, last week, how much time did I spend, So it's difficult. It's usually, you want to stay away from subjective features here, if you can, right? Anyways, and then the labeling was done manually, right? If you read up on the paper, you notice it was done manually here. And again, here, because you're interested in learning a model that will spit out high intervention and low intervention, the type of learning here is classification, specifically binary classification. There's this, again, this really interesting thing. It's a bit odd here, but what these people are interested in doing is, given a document, right? So they were obviously working towards building this platform which was meant to house or to store millions of documents, right? And so the thinking is, if you have millions of documents, how can you make it possible for people to find what they're doing? Browsing, right? By category. Yeah. So it's like you have this web-based application which has millions and millions of documents. For people to easily find what they're looking for, in addition to searching, what you'd want to do is to build this in such a way that somebody can indicate to say, I'm looking for books, of slides, for resumes, for instance, or CVs, or for papers, right? And so they were building a model which was meant to indicate if a document, an input document, was a book, slides, a long document like a thesis, a dissertation, a paper, a resume. And if you read up on this paper, on this publication, it's quite interesting, really. They identified a broad range of features, and these were not, when you see something like file-specific features, it's not like it's one feature, right? So it's a subset of X's that were tagged as being file-specific, right? There were section-specific features where you're swallowing this document, and then you see these structural elements of the document, right? The sections and the subsections. And using that information, you can infer what sort of document you'll be dealing with here. And containment features. Now, at your own time, again, I do encourage you guys to maybe look at this paper. It would be nice to look at some file-specific features so that people have an idea. It actually gets quite interesting when you become more nuanced like this, because there are interesting problems like, how do we identify the file-specific features? Where are we going to get them? That's sad. It's no longer there, I guess. Document type classification in online digital libraries. In online digital libraries, I guess libraries. Hopefully I'll be able to find this this piece of, you probably want to look at this. It's a classic at the time anyway. This was a pre-LLM. This was during the pre-LLM era, and a lot of things that can easily be done now were quite difficult back then. So if you read through this, you begin to notice a long time ago here, so like 9 years ago or something like that. I don't know. But what you begin to notice here is that the features, right? Structural features. Look at this. They're saying we identified things like the size, right? File size, the number of pages, the page count, which is quite interesting, right? If you look at the assumptions I'm making, the intuition is that generally scientific documents vary in size, right? And number of pages. It's quite interesting. And then they have also text-specific features here, where they're looking at the length of the text characters, document length, the number of words, number of lines, and all those things. So a combination of this enabled them to learn a model that classifies whether a given document is a book, slide deck, a thesis, a paper, or a resume. And if you look at this, right, what you begin to notice is because you're outputting categories, this is a classification problem. More aptly put here, because you're outputting more than 2 classes, is a multi-class classification problem they were solving. Anyway, again, if you read up on this, the labeling was done manually. You know, this issue of labeling, by the way, is can be quite costly. I did an exercise as part of I'll discuss it, I guess, when we look at multi-label classification here. But a while back, I hired a group of 5 students, and their task during one of the vacation periods, I think it was a December vacation, they'll show up to the lab. A few other things here. Yeah, Mr. Benayas, I don't know what's happening. I don't know if you're drunk again. You know, this is it's becoming irritating, right? You're probably drunk here. It's Saturday or something. I'm gonna assume you're drunk here. Apologies if you're not drunk, but this keeps on happening, right? And it's not very nice, is it? Not very nice at all. It's actually horrible, right? What you're doing is pathetic and horrible, really, to be honest. I think it was it must have been in 20, I don't know if 20, I don't know if it's 2021 or something, where I had these guys, was it 2019? I don't know. I'm literally forgetting here, but I had these guys create, they were working on a labeling problem here. There we go. So what I did was I identified students that were capable, and then during the vacation period, they'll show up. There was a short training session where I walked them through what they were supposed to do, right? And then I prepared some manual, like what you're seeing on the screen right now, a quick guide, because I'd leave them in the lab, right? They show up in the morning, they leave in the afternoon or something around 16, and their task was to label the things in the repository, right? So I assigned each one of them documents to label. So the column A here indicates the person who was doing the labeling and the stuff that we're doing here. So you notice here we're labeling quite a bit of stuff. There's Matthews, there's Hawkins, there was Wesey. These guys have since gone here. And so what they were doing is, for all of these 3,268 documents, they would open up the document, and I made life a lot easier for them, right? I'll give them a link to the document. You open up the document, you download it in essence, you open it up. In fact, when you click on the link, it takes you to the landing page. Here, from the landing page, you download the document. When you download the document, you start taking note of important information about the document, like the title, the creator or the author, the year it was submitted. These were ETDs, by the way. The degree, right? Including details of who the supervisors were and stuff. So it was quite fun, but very costly on my part. And it turns out that this label dataset has been used in a number of projects that we've done in my lab, right? Anyways, so there's that, right? Manual labeling. And then this is a multi-class classification problem. And then there's an interesting piece here, the Moodle predictor. The idea behind this is, I think these people are interested in determining people who are at risk of failing or something, right? Using behavior and interactions within the Moodle. So the idea is, can we look at how users or how students interact with the Moodle, the learning management system, to try and determine if we can use that information to determine if a student is going to fail or not. It sounds a bit far-fetched here, but it turns out that what the outcome of this will be able to give you information that will, to a certain extent, enable you to identify struggling students in this particular case. Not too long ago, I was going through a piece, right, at CBU, where a paper at CBU, it's a paper done at CBU where the Yeah, I don't know about that here. But the authors were interested in predicting students who, how students would fare, right? How first-year students would fare. So is this student going to go on part-time? Are they going to proceed or something? Are they going to have to repeat and all those things? And for them, the features that they were using, I guess I can probably be able to find this here, but the features that they were using, there we go, this one here. The features that they were using are things like, I think high school, you know, you guys, Mr. is it Chikumbo, something like that? I don't know what you're doing here, right? It's unfortunate that you know, can't teach you etiquette, is it? How to behave when you're around other people, right? You know, I mean, if you want to act a fool when you're alone here, it's fine. But anyways, so it's Moodle predictor, and then we looked at an example of spam, right? If you're interested, if you are tasked, for instance, to build a spam filter, you know, you could perhaps use things like the originating email address, things like the contents of the email, the subject, the writing. Although I don't know about the writing now, it's just a matter of time before, you know, these people that create these spam messages will be smart enough to start using ChatGPT. And what you can do is you can just tell ChatGPT, you know, there's this message I want to send. Can you write it in such a way that it's professional, and make sure that you work on the casing, right? So that you stop seeing a lot more of things like find your match on eHarmony today or something, or things like infographic, well, maybe not here, but say what we've extended, blah, 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 right? You can tell that some of these things are literally spam, right? Anyways, and then another example is the BNNB. I like using this as an example because when we start looking at how to build regression models, hopefully tomorrow, if not Tuesday, I'll use the JCTR dataset as an example, right? To showcase that we can actually build a very simple linear regression model that will be able to help us predict the BNNB for December, you know, to a certain reasonable, to a certain level of accuracy here. And then you have, you know, unsupervised machine learning, where we see that, you know, there are no really specific values that you're predicting here. You're just interested in patterns, right? Like, for instance, if let's say I pull out information from Go Zambia jobs, right? And maybe I'm just trying to, you know, come up with a pattern of jobs that are posted there in relation to things like expected, you know, salaries, and I'm using qualifications and the domain and experience, perhaps including references as X's or as inputs, right? African queen talking about melanin. Yeah, hey, guys, do you want to behave? Yeah, I'm recording this. I'm gonna take this serious because I think it's becoming like a joke or something, right? You know, you're being stupid here because I don't expect you to behave like this in fourth year. Yeah? We shouldn't really be behaving like this in fourth year. I'll leave you with this. You know, the fact that we're going to focus on regression, classification, and clustering in 4792. And just to mention that a lot of things that you see around, actually, like these real-world examples, really classic examples of the things that we're going to be doing, right? You know, so language translation, for instance, on social media platforms like Facebook, things like Smart Compose. And of course, these we use more sophisticated things here, right? Like predicting the next word or something. But it turns out that there's the basic fundamentals are the things that we're going to be looking at, right? You notice that in some dating apps, I've taken quite an interest in some of these platforms myself, because it turns out that they have quite a rich data set, right? So if you're verifying your account on a platform like Tinder, for instance, you notice that you can view that as a machine learning, supervised machine learning type of problem, right? Because what they'll do is they'll do a comparison between all the images that you have on your profile with this, I want to call it the live feed, right? You take a selfie or something like that of yourself, you know, and some examples that are related to maybe the group-based projects here is a problem that we looked at, which used as input texture content, right? So we were extracting titles and abstracts, combining them, and then we vectorize them, right? We used those as input to try and predict the type of ETD, whether it was a doctoral dissertation, a master's, a doctoral thesis or a master's dissertation, and things like whether, or what sort of subjects would be associated with the dissertation itself. That's a multi-level classification. And also, in addition, trying to predict like the collection, right? Within which that dissertation is supposed to be deposited or something like that. So some other things that we've been doing with Department of Radiology as well can be viewed as, or they are classification problems, where we're using as input a DICOM file. I think I gave this example at the very beginning of the course. And so using this as input, what the classifier does is, it tells you whether the DICOM file is associated with pneumonia or not, right? And then the localization part of the problem here works in more or less the same way, right? You have these images, right? You label them in such a way that you're indicating, say, on this image, this section is what is problematic, and this section here. So when you have a lot of these images, which will have specific locations which are problematic, the model will note the next time it's given as input something it hasn't seen, to say the problem should be here, because based on the examples I've seen, anomalies have these sort of features, right? These are image features, the pixel representations. Anyways, so when we meet tomorrow, we're going to talk a bit more about how we get to prepare data sets for supervised machine learning. If you remember, we mentioned that one distinct feature when you're comparing supervised machine learning with unsupervised machine learning is that with supervised machine learning, you need a labeled data set. So the question is, how do you create this labeled data set? So we're going to look at that. And then immediately afterwards, we're going to talk a bit more about training before we start looking at how exactly we go about implementing, right? I want to get us to a stage where we understand the basic concepts before we start, importing those things from scikit-learn, right? All right. I'm going to leave you. I think we can leave it at that, unless if there are any questions. I think enough chaos for today. Unless if there are any questions or thoughts.
So I've got a question.
Yes. Yeah. Yes, please proceed. You have the question?
Yes, sir. It's about the lab for modeling. We're confused because other people are saying the techniques can't work without a larger data set. So I'm confused because our data set is small. So are we supposed to like increase the data set, or it can still work with the same data set we have?
Well, I mean, I don't know what sort of data set you have. I don't know how many observations you have. What's the size of your data set, right? How many documents do you have in your data set?
They're 120. About 120.
Yeah. Yeah, I mean, it may not work, but for the purposes of for the purposes of what we're doing, it's okay. I mean, your accuracy is not really going to be that good, but it's fine. If you can get slightly more, that would be better, right? Aim to get at least a minimum of 200, and I forget the sort of.
So it's all right. We can use the same data set we have.
Yeah, maybe just increase the size of the data set to maybe 200 instead of 120, which you can do, right? because you see, the thing is, you'll notice tomorrow that one of the things you're going to have to do is you're going to have to split that thing. At the very least, maybe you do a 90-10 split, right? Where you're saying, you know, kind of like 10% of the data that you have is going to be is going to be used for testing, and 90% is going to be used for training, right? So it's like 0.9 of 120. What you're saying is 118 observations will be used to learn your model, and then 12 will be used for testing. Now, that's not good there, right? If you decide to use a 70-30 split again, so my advice is stretch it to 200 so that you get better results. Because if you stick with the data set you currently have, you end up having a model which is probably going to be, it's not going to be as effective, right? So the accuracy is going to be so very low. And I guess you can justify that as a limitation. You know, this is the way we're going to score you here is we are taking into account the fact that you know, this is being done to teach you how these things are supposed to be done, right? In a real world setting, you'd obviously need significantly more data, but stretch it to 200. I think you can manage. Is that fine? And then there's a question from Stefan.
Afternoon. Good evening, sir. I wanted to ask about quiz 5. You mentioned during our last quiz to say we're going to have quiz 5. So I wanted to find out when exactly we're going to have that.
Yeah, you know, I think I may have said maybe, and I was looking at the time, right? Because we have the test on Thursday. The only time we can have quiz 5 is during the study break, and I don't want to have to answer to someone why I was giving assessments a few days before the exam. So we'll leave it at 4 quizzes, with each quiz being allocated 2.5 marks. And if you notice from the spreadsheet tracker, right, you notice that I've actually updated all the quiz grades, and the spreadsheet has actually been designed in such a way that we only go up to quiz number 4. So we'll not write quiz number 5. But don't worry, there'll be plenty of questions on modeling and evaluation in the exam. Is that fine?
Yes, sir.
All right. Thank you very much. All right. Unless there's any other questions, I think Benaya has a question.
Yes, sir. Our data set, it has like 50 rows. So
No.
I wanted to ask,
No.
okay, you told us to get the data from Jonas. So there's like a few Jonas articles that are there. So how are we going to find other articles to make it like 400 or 200 articles?
How many articles are there in Jonas?
In the Jonas, another thing that you told us to find, there are about 4750 PDFs that we found from them. And I don't think that data is enough to train the model. So I wanted to ask how.
So it's like enough actually. It's so for in your case, right? And we're not really going to cover this, but if you want to be fancy, you can look into how to create synthetic data, right? Yeah, to augment whatever it is you already have. But here's the thing: I'm going to leave you with this. You want to, because I'm going to use this as a teaching aid or as a learning aid or something when we start looking at this. I don't know, Tuesday or tomorrow or something like that. You see this number here. You start here, right? Are your samples or observations greater than 50? If not, get more data. If they're more than 50, are you predicting a category, right? Do you have labeled data? You see that? Is a sample less? So this gives you an idea of like the estimators that you could perhaps plan to use in your case, your unique case where you can't get more than the number of records you're working with. You see this? So 50 will be fine-ish, right? I mean, the model that you want to implement is not really going to be that accurate, but you want to be smart about the specific estimators that you're using. But I'll have to check Jonas here. I suspect, I think we have slightly more than that. We can't have 50, but that's fine. That's fine. Are there any other questions?
What about the class participation? Are you going to update it? Like you
Yes.
ended on 15.
I will update it. I have all the records. I've been behind quite all right. That is going to be updated. Well, there's a directive the CA is supposed to be shared with you before the exams start. So very, very soon, in fact, before the end of next week, expect most of these assessment categories to be updated. So the only thing that's going to be pending is the lab, because you need to present, and the test. So yes, it will be updated. Which is good, right? These are free 5 marks. So if you've just been attending classes, you're going to get free marks there. All right. I don't know if there are any other questions. Please study for the test, right? The test is not going to be like the labs where it's just programming questions, but yeah, there'll be a bit of theory. Yes.
Yes. I have a question. I sent over an email with my answer to one of the quizzes, lab 3, and the correct answer, which I was referencing from the Jupyter notebook, as you told me to do, but I didn't get a reply.
Yeah, it's probably, I'm a bit behind with my emails. I will get through to that and I'll respond. I know there's somebody else who, I don't know if it's you, they sent through in a quiz. They were, so I forgot to, my tallying was not on point, ideally. Listen, I have to exit, but I'll respond to all the emails, right? If there are more questions, I'm supposed to transition here. Please direct them to my email or something like that. Thank you very much, everybody. Sorry, I have to rush out.